This video will prepare you for section 8.5, which examines the general quadratic in two variables. What we mean by the general quadratic in two variables is the following. So you can have a quadratic term in x. So let me just sort of highlight what I'm talking about here. You could have a quadratic term in x, a quadratic term in y, and although we haven't really considered this much, you can multiply x and y together, and then that term is also considered quadratic. And then you can have a linear term in x, a linear term in y, and a constant. And that's pretty much all you could possibly have. And it turns out that in general, if a, b, and c are not all zero, meaning there's at least one quadratic term in the equation, then the graph is going to be a conic section. Or to be more specific, the graph will either be a circle, an ellipse, a parabola, or a hyperbola. There is also the case where there's no solution at all, and the graph would be empty, although we won't really address that in this class. Also, something we won't address in this class, none of our examples are going to have this xy term in them. That's something you'll look at in a future math course. If there is an xy term, it's going to be one of these shapes, but it might be rotated. It might not be horizontally aligned or vertically aligned. Again, that's some interesting mathematics that you'll examine in more detail in a future math course. For now, the only quadratic terms will be x squared and y squared. And please note that a, b, c, d, e, and f are always going to be numbers in our examples. Okay, so you might wonder, if you're given a quadratic equation in two variables, how do you know what the graph is going to be? Well, the typical approach would be to rewrite it in standard form. So it's worth reminding ourselves what standard form looks like. So for circles and ellipses, I've just displayed the general form for those equations. Actually, I shouldn't say general, the standard form for those equations. Remember that in both cases the center is HK. In the circle, there will be a radius, whereas in the ellipse, it's going to be equal to 1, and there's going to be a vertical and horizontal stretch. Okay, we also have equations for hyperbolas and parabolas, and notice that in those examples I give you two versions of standard form depending on whether the graph is horizontally aligned or vertically aligned. So you should already be familiar with all of the equations on this screen and know how to use them, because that's what I'm about to do now. So here's an example of a general quadratic, and I'm going to put it in standard form. Well, standard form, let me just go back. In every single example, standard form, the variable is in a quantity that is squared, which means we're going to have to use completing the square to do this. So here we go. I'm going to group my x terms together. So x squared plus 10x. Then I'm going to leave space to complete the square. I'm going to group my y terms together. Y squared minus 4y. Leave space to complete the square. And I'm going to move my constant, positive 20, over to the other side, and it's going to become negative 20. Now I'm going to complete the square on x as well as y. So I look at 10, split it in half, that's 5, and square that, so add 25, which means I better add 25 on this side as well to balance the equation. Alright, and then I'm going to complete the square on y. So I take half of negative 4, which is negative 2, square that, and I get positive 4. So I'm going to have to add a positive 4 on this side as well. Alright, now that I've completed the square, I can write that as x plus 5 squared plus y minus 2 squared equals, and if you add all that up, you get 9. Now that it's in standard form, I know that it's a circle, and I know that its center is hk, or negative 5, 2. And I know that its radius, well, radius squared is 9, so the radius is 3. By the way, I could have known that this one was a circle because x squared and y squared are both positive and both have the same coefficient, in this case 1. And I'll talk more about that in class, but that's an indication that you've got a circle. Okay, so that's how you put it from general form into standard form, which would make it much easier to graph. There is a second way of doing this, and that would be to graph it on your calculator. In order to do that, you're going to have to solve for y. And in a lot of examples, students really like using their calculators. I'm wondering how you're going to find this process. It's kind of a different way of thinking. So what I'm going to do, I want to solve for y. So I'm going to think of this as a quadratic equation in y. So y squared minus 4y. So I've already taken care of this term and this term. Notice the other three terms do not involve y. So I'm going to group them together, plus x squared plus 10x plus 20 equals 0. And in order to solve for y, I'm now going to use the quadratic formula on y. And I'm thinking of a is 1. The coefficient of y squared is 1. b, the coefficient of y is negative 4. And here's the part that's kind of different. For c, our constant, we're going to take all of the terms that don't involve y. So in this case, x squared plus 10x plus 20. And then we plug that into the quadratic formula. So that's going to look like this. Y equals negative b, so that's 4, plus or minus the square root of b squared, well, negative 4 squared is 16, minus 4 times a, well, a is 1, so I'm not going to write that, times c, x squared plus 10x plus 20. Let me make my square root a little longer. All over 2a, which is 2. And you could clean that up a little, although the purpose of doing this is to graph it on your calculator. But for myself, just to make it easier to enter on the calculator, I'm going to distribute that negative 4 minus 40x minus 80 all over 2. If you graph this on your calculator, and you'd actually have to graph two functions, one with the plus and then a second with the minus, the plus sign should give you top half of the circle, and the minus sign would be the bottom half. It might look elliptical, but if you zoom to a square window, it should look like a circle. I can help you with that in class next time, but it's worth being able to do. So again, you use the quadratic formula, but you take, oops, I forgot a parentheses here. You take everything that doesn't involve y and make all of that your c, or constant term. Okay, this is a lot, but I want to go through another example with you. I'm going to take this general form and rewrite it in standard form. So I'm going to put all my x terms together. In this case, there's only one, 16x squared. And then I'm going to take my y terms and factor out the quadratic coefficient. So that will be y squared minus 25 times 6 would be 150. Going to leave a blank space to complete the square, and then move the constant over to the other side. It becomes positive 175. Okay, notice I don't need to complete the square on x because the x only shows up as x squared. So it's already fine the way it is. Now, to complete the square on y, half of negative 6 is negative 3. Negative 3 squared is positive 9. So I need to add a 9 to the other side as well, except it's really 25 times 9. And 25 times 9 is 225. Okay, so 16x squared plus 25, y squared minus 6y plus 9 factors into, oops, y minus, not y plus, y minus 3 squared, and 175 plus 225 is 400. And then I'm going to divide everything by 400 because this isn't going to be a circle. Since the x squared and y squared have different coefficients, it can't be made into a circle, so I want it to be equal to 1. And then 16 over 400, well, that reduces. 400 divided by 16 is 25. And then I get plus, same thing here. The 25 is going to cancel with the 400 16 times. And there you have it. So now I know that this is an ellipse. And it is centered at 0, 3. And it is going to be horizontally, it's going to be 5. And vertically, it's going to be 4. That's the square root of these numbers. So, you know, it's going to look something like that. Centered at 0, 3. Okay, for your homework, there's one general quadratic equation. You are to do both of the things that I went through in this video. First, rewrite it in standard form. That will involve completing the square on x as well as y. And after you've done that, solve the equation for y. You'll have to use the quadratic formula, and if you do it correctly, you should be able to enter it into your calculator and see it. Okay, have that ready next time.